Okay, so on this first one, we're going to use mental math to solve. So, and what is our strategy? So what's 9 squared? 81. Good. What's 9 to the negative second power? What do we do with negative exponents? We flip it. Okay, and then now what's 9 squared? So we're going to have 1 over 81. What's 9 to the 1/2 power? Doing that on Monday. Raising something to the 1/2 power is the same thing as taking the square root. Okay, so square root of 9 is what? 3. Okay. If I have 9 to the negative 1/2 power, what is that going to be? I think somebody said it, 1/3. Bless. All right, so today we're going to extend our understanding of fractional exponent and the exponent rules to negative exponent. Okay, so for each, write the equivalent expression using radicals. Okay, I'm going to help you with the first one. Remember, yesterday or Monday, we learned that when we take the square, or not the square root, if we're taking some type of root, then we can write that as a rational exponent, which will be x raised to the exponent divided by the index. Okay, so we're going to use that to help us here. So we know that we're going to have a root. We're going to put 17 underneath the root. That denominator is going to go in that little cubby hole, and the numerator is going to be that exponent. I want you to try B. The only difference is there's a negative. Now remember, negatives flip the fraction. So this is going to be 1 over something. Can you take a second? Can you try B? All right, so what did you come up with? I know that there's going to be a root. Where do I put numbers? Two goes in that little cubby hole, right? All right, where's the 31?
31.
Cubed. Yep. Just backwards. So you're going to write this in an exponent form. Or I'm sorry, in a rational exponent form. So just a reminder, if there's nothing written here, what number do we assume? 2. Okay, so we're going to have 3 raised to the 4 divided by 2. Can we simplify that at all? What's 4 divided by 2? Okay, so this is going to be 3 to the second power. Can you take a second? Can you try the next one? So just like what we said, we're going to keep 1 divided by in the top, and then we're going to rewrite this bottom. Okay, so we're going to have 5 raised to the what? Yeah. To the, okay, divided by, okay. Can we simplify 6 divided by 3? Yeah. So what? 2. Okay. All right. So for each set of 3 numbers, cross out the expression that is not equivalent to the 2 other expressions. So for instance, we have this 8 to the 4/5. Okay. How do we write that out in radical form? Well, we're going to put 8 underneath the radical. We're going to put 5 in the little cubby hole, and 4 is going to go as my exponent. So, ta-da, this guy is wrong. Okay. Can you take a second and can you look at the next three and see which ones you're going to cross out? So on this first one, we've got this written out. And when we're going to rewrite this in radical form, there's that negative. Negative means that we're going to flip the number 8. So that means we're going to have 1 over 8. We know that there's going to be a radical. That denominator is going to go in the little cubby hole. And that exponent is going to go right here inside. So which one is written like that? The middle one. This guy's wrong. Okay. On C, we've got this radical written out. Now, how do we write that in the exponent form? Well, we know that 2's in this little cubby hole. Okay. So when I want to write it out in exponent form, I'm going to put 4. We're going to raise it to the 3 divided by 2. So what's in that little cubby hole is going to go on the bottom. What the exponent is going to go on the top. And so that's going to be this guy. The last one, we have this radical. Since we see that it has 1 over our radical, we know that the exponent is going to be negative, right? So we can go ahead and say that it's this one. We don't even have to do anything because this one doesn't have a negative exponent. But if you didn't know that, we would write this out as 4. We got negative in the exponent. 3 is going to go on top. The little thing that's in the cubby hole, which is 2, is going to go on the bottom. Ta-da! On to the other two. All right, so on these two, are they equivalent or not equivalent? They're equivalent, okay? The reason why we know is because that exponent is going to go here. It's okay if it's on the outside or if it's on the inside. It's the same thing, okay? That trips up a lot of people, the same thing. This denominator is going to go in this little index box, okay? All right, on number 2, are they equivalent or not equivalent? Equivalent, okay? Don't let the negatives be that big of a deal. Remember, if it's negative, it's going to flip that fraction. Okay. Say again? 64 is just, yeah, whatever the number is. Yeah. What? So let's talk about this first one. Oh, is this one equivalent or not equivalent? Which one is it? Okay, tell me why. Okay. Okay, so just looking at this guy, right? So if we start with this, we know that negative means we're going to flip, right? But there's no denominator, right? So is there any radical that we're going to put? No. So these are not equivalent. So here it is again. There's no denominator in that fraction, so there's no radical. We're not going to take the square root or the cubic root or whatever. Yeah. All right, on the next one, we've got this. We got 8 to the negative 2/3. So what do we do with negatives? Flip the fraction. Okay. We know that we're going to have a root because we got a denominator. What's going to go in this little cubby hole? And then what's going to be my exponent? Okay. But they got 1/4 as their answer. So can we simplify this fraction? What's 8 squared? 64, right? Now, if we take the cubic root of 64, that means we need to have a number that if we multiply it by itself 3 times, we get 64. What's that number going to be? 4. So this can be simplified down to 1/4. See how I did that? Okay, so here it is again. We went from rational exponent, turned it into a radical, squared that 8, then took the cubic root of 64. If you're like not sure about this one, you can use Desmos on this guy and it'll help you. And we got 1/4. Ta-da! No. So on this first one, we don't have an exponent inside of here, but we have it raised to the 1/2 power. Anything raised to the 1/2 power is the same thing as doing what? Taking the square root. Okay, so I can rewrite this like this. Now this looks a little scary, but if you separate this and break it down, what's the square root of 9? 3. What's the square root of 4? So this answer is 3/2. Okay, so it's not as bad as you think. Huh? Just be 7. All right. On the next one, we're dividing. That means we're going to subtract my exponents. So I'm going to take 5/2 minus 1/2. Remember, when we're adding or subtracting fractions, we have to have the same denominator, which we do. So what's 5 minus 1?
4.
And then we have 2 in the bottom. Can we simplify 4 divided by 2? What does that give me? No. 2. That's okay. All right, so our final answer is going to be 3 to the 2nd power. You could write that out as just 9. That's okay as well. Okay, so if we're dividing, we're going to subtract those exponents. Okay, on the next one, we're multiplying, so that means we're going to add the exponents. Well, there's nothing written right here, so what do we assume this guy is? It's right here. What exponent does it have?
No, a 1.
It has a 1 as an exponent, right? Now, we want to add these exponents. So we're going to do -4/3 plus 1. Well, these don't have the same denominators. So how do I change 1 to have the same denominator as 3? What am I going to do to this 1? I'm going to multiply it, right? So I'm going to multiply it by 3 in the top and multiply by 3 in the bottom. So when I do this, I'm going to get -4/3 plus 3/3. What's -4 plus 3? -1. 3 in the bottom. So we're going to have x to the -1/3. Okay, so fun fact, mathematicians do not like this negative exponent. So in order to get rid of that negative exponent, I can flip my fraction and keep that exponent. I just work here. Yeah, come here. So we're going to simplify each expression and we're going to write our final expression using only exponents. Okay, so we've got the square root of xy raised to the 3rd power. If there's nothing written here in this little cubby hole, what do we assume it is? 2. Okay, so if I want to rewrite this as an exponent, I'm going to write xy, and I'm going to raise it to the 3/2. This is actually saying, hey, take x, raise it to the 3/2 power. Take y, raise it to the 3/2 power. So this also could be written out as x to the 3/2, y to the 3/2. Yep. I just work here. All right. looking at this next one. Okay, ready? So we want to write this in exponent form. So this first little radical, we're going to rewrite this guy in exponent form. So we're going to have x to the 4/5. Everybody see where I got the 4/5 from?
Yeah.
Okay. We also have this y to the -2nd power. That means that we're going to put this guy on the bottom. We're going to take this y to the second, we're going to put it on the bottom. Okay, because remember how negatives flip the fraction. It's going to go to the other side of the denominator. I'm sorry, the other side of this division line. Okay, that x is just chilling up top. Now we know from our exponent rules that if we're multiplying these two things, that we can add the exponents. But this guy doesn't have an exponent, or at least they don't have one written. What do we assume this guy is? A 1, good. We can only add exponents if they have the same denominator. So we're going to take this 1 and we're going to multiply by 5 in the top and 5 in the bottom. So it's now going to become 5/5. They now have the same denominator, so we're going to add 4 plus 5, and that's going to give us 9/5. And we're just going to keep that y squared in the bottom. We can't add the x and y's because they don't have the same base. One, we're going to write this in radical notation. So you really have to pay attention to whether they want you to write it in exponent form or radical notation. Okay, we learned last week that if we have an exponent raised to an exponent, what are we going to do with those two? I heard it. Multiply. Okay, so we're going to multiply 3 times -1/3. Okay, so 3 times -1/3. When we multiply fractions, we're going to just multiply straight across. So that's going to give us -3/3, which would simplify to -1. So I'm going to rewrite this x as x to the negative first. We're also going to raise that y to the -1/3 power. Okay, so we got y raised to the -1/3 power. What do we know about negative exponents? Yeah, what do? They flip the chicken. They flip the fraction, right? No? Yes. Okay. No. Negative exponents flip the fraction. So we're going to get y to the 1/3 and x to the first power, which we can just write as x. Now they asked us to write this in radical notation, right? So how can I write y to the 1/3 power in radical notation? Your stunned silence is very reassuring. Come on. We got the cubic root of y to the first power over x. Ta-da. Okay, so on the next one, we see that we got an x in the top and an x in the bottom. We're going to subtract those exponents, but they have to have the same denominator. So we're going to have 3/4 minus 1/2. How do I change this to have the same denominator as 4 over here? Not divide. There you go. So this is going to be 3/4 minus 2/4. So 3 minus 2 is going to give me 1. So this can be written as x to the 1/4 power. Over here, we've got y's. We're going to subtract those exponents. So we've got 1 minus 2. 1 minus 2 is going to give us -1. So this is going to be y to the negative first. Again, they want us to write this out in radical notation. So in order to write this x to the 1/4 power in radical notation, we're going to say the 4th root of x to the first. And this negative exponent is going to go onto the bottom. So it's going to be y in the bottom. Okay, looking at this first one, did they do this correctly? What's the first thing that they did? They
It's over.
They wrote it in wrote it in rational exponent form, right? Okay, so they put it in an exponent form. Okay, then what did they do? Stop working it out. Start working it out. Okay, so they took exponent, raised it to an exponent, so they started multiplying, right? Okay, and then once they multiplied, what they could do from here to there? They simplified, right? So did they do it right? Whatever this person's name is, Janet? Yep, we agree with them. Cool. Definitely going to be some type of error analysis question on your test. It's gonna be very similar to this. Yeah, I know. Okay, looking at the next one, the one that's in the middle. Do you agree or disagree? Take a second, look it over, see if you can find an error. Okay, looking at this next one, where did they mess up? Yes, sir. Yeah, go ahead. Oh, yeah, come here. Thanks, babe. All right, so where'd they mess up on this one? So what's the first thing they do? Nothing? What's the first thing? Again? So what would you do if you were looking at this first problem? You got power raised to a power, so what are you gonna do? Multiply. Good. So we multiply those exponents. Okay, they did everything right there. And then what are you gonna do on this row? This guy. So you add the exponents. Good. Okay, so you're gonna add those exponents, and you could simplify this -6 divided by 3. Okay. So it's gonna be -6 divided by 3 would give me -2. So that's right. Now we're gonna add the exponents. So if I add 4/3 plus 2, I need to have the same denominator, right? So how do I change this to have the same denominator? Put a what? Put a 1 under it. Okay, and then what? Should I add them? I can't add these because they don't have the same denominator. So what am I going to do with this guy? Okay. So this will be 4/3 plus 6/3. What is 4 plus 6? 10 over 3. Is that what they have written here? No. So we disagree because they didn't add those fractions together. Does that make sense? Okay. Yes, they put 8 over 3. I don't know how I got that big multiplied. Yeah. What's up? This last one. Okay. We have a cubic root of something raised to the 18th power. So what they did from here to here is they went ahead and wrote this as a rational exponent. Then they multiplied 18 times 1/3 and they simplified it to 6. They distributed out this exponent to each part. So that's x to the 6, y to the 6. And then what are we going to do from here to here on that last step? What are we going to do? Not really. Not really. That aggressively huge. There we go. Okay, so from this one to this one, the last two steps. What are you gonna do with those exponents? Subtract. So what's 6 minus 2? 4. So is that what they put here? No, so they subtracted wrong. So we disagree. Yep. And then 6 minus 1 would give us 5, right? And again, they subtracted wrong.